Hey guys, so now that we finished the project, we're going to move on to the last chapter, which is statistics, which is a chapter that I like for obvious reasons. If you don't know, I am the AP statistics teacher, so if you are taking statistics next year, this is definitely a helpful chapter to get you guys started up to what we can finish at least. And if you're not taking statistics next year, one day you will take it in college. And even if by the rare chance you do not have to take some sort of intro statistics course or business statistics or something along that nature, statistics is something that you can use in everyday life just to make better informed decisions. So, what is statistics? Statistics is the science of learning from data, and statistics are widely used to make claims about a very large group based on the observations of a small group. It's kind of incredible how we can tell more about an entire population just by taking small samples from a population. Now, what is a population? The population is the entire group of interest in a statistical study, and a sample is a small subset or group chosen from the population. You take a sample from the population, right? You like to think of a sample as, I like to do this. I like to say, if this is the population, right? This is the population, then the sample is a piece of the population, okay? Now, samples should always be chosen randomly from the population of interest. And this word random is, if you take AP statistics, you will learn one of the most important words of all of statistics. We use samples to make generalizations about populations. So, example one, an orange juice processing plant receives a truckload of oranges, and the quality control team randomly chooses 3 pails of oranges, each containing 50 oranges from the truckload. Right? So they're going to check these oranges to make sure they're all right. They can't check all of them, so they just check a random sample. Right? So identify the sample and the population in the given scenario. So the sample that they're checking are the 150 oranges in the 3 buckets, and the population would be all oranges on the truck, right? So again, you can kind of see this kind of makes sense. Why would you check every single orange? It seems like a complete waste of time. Randomly check some oranges, and if those are good, then we might be able to say more about the population. So in fact, it says state one conclusion that the quality control team could make about the population if 5% of the 150 from the sample was found to be unsatisfactory. So what can we say? Well, if we take a good sample, then if 5% of the sample is unsatisfactory, then they can conclude that approximately 5% of the population will be unsatisfactory. Now there's a key word here. What's the key word here? The key word is approximately, because it's not going to be exactly 5%. It could, but it's very unlikely that it's exactly 5%, but you're taking a rough estimate based on a good random sample. Now, bias. Bias is any flaw in a study. So it's the design of a statistical study shows bias if it would consistently either underestimate or overestimate the true value that you want to know, the true population, right? A study is biased if it systematically favors one outcome over another. When bias is present, the results are not reliable. We like to say they are not representative of the population, right? For example, you'll see all these different examples, but the easiest one I can think of is if you want to know if people like playing football, you should not survey only the football team. That would lead to bias as an overestimate, right? If you want to know if people think baseball or lacrosse is a better sport, based on their opinion, you should not only ask the baseball team or only the lacrosse team, right? You need to take random samples. So here it says, to minimize bias, we must use randomness when selecting a sample. Randomization is an important part of any statistical study. Participants should not self-select in a sample survey. Okay, so this sentence that participants should not self-select is when people are given the option to give their opinion, it's more likely that they will have a strong opinion, right? These are like call-in interviews, or like if you take an online poll, people just ignore. How many online polls or online things do you see you just ignore? But if you really feel strongly about something, it could lead to bias because you'd be more likely to answer. So randomness is what we want. And when you get to statistics, you'll learn we're looking for what's called an SRS, which is a simple random sample, an SRS. So, Cheap and Fast Gas Station is conducting a consumer satisfaction survey. Which method of collecting data would most likely lead to a biased sample? Okay, so which one would lead to bias? Interviewing every fifth customer to come into the station. It's not really a random sample. It's random enough. It's good enough where that there's no really pattern. It's not like every fifth person is going to be more likely to like or dislike the gas station. So no, that's fine. It's not really going to lead to bias. Interviewing customers chosen at random by a computer at checkout. That sounds like a great sampling method. That's not going to lead to bias. Interviewing customers who call an 800 number posted on the customer's receipt. Okay, now think about this. If you get a receipt and it says, "Tell us how you feel about your day. Call this 800 number and tell us what you think." Are you going to call if you pumped your gas, it was great, you drove away, and you went on the rest of your day? No, people don't really call for that. Who are going to be the people that call an 800 number to give their opinion about the gas station? People who are pissed because something went wrong, or people who are not happy because maybe the place was dirty, or maybe the gas pump broke, or maybe the credit card thing didn't work. This is definitely going to lead to bias. And if you had to take a guess, it would lead to bias in which way? It would lead to bias in that the survey results would show that people didn't like the gas station, but that might not be true. Okay? Which statement about statistical studies is true? Okay? So, this is a good question to understand that your sample should be a good representation of the population. So it says, 1. A survey of all English classes in a high school would be a good sample to determine the number of hours students throughout the school spend studying. Yeah, sure. If you go to each English class, almost every single kid has an English class, so it would be a good representation of the population. And it's not like kids in English are taking all different classes, because you could be in English and be in AP courses, you could be in English and be in, English as a second language courses. It doesn't matter. It's a good representation of the population. This is pretty good. A survey of all ninth graders in a high school would be a good sample to determine the number of student parking spaces needed. No, ninth graders get driven to school by their parents. I see them dropped off every morning. They wave goodbye. Mom says they love you, and you say, "Leave me alone, Mom." No, that's not good because they're not parking cars. Number 3, a survey of all students in one lunch period in a high school would be a good sample to determine the number of hours adults spend on social media websites. No. I mean, you're not going to ask a kid how much your parents go on social media. How do you know what they're doing at work? They're probably just scrolling through TikTok just like you guys, and you don't even know it. So, no, that's not a good way to take a sample about adults. And then 4, a survey of all calc students in a high school would be a good sample to determine the number of students throughout the school who don't like math. There are a lot of kids who should be taking calculus but don't because they don't like math, right? Or should be taking AP statistics and they don't because they don't like math, which doesn't make sense because it's less math than you think. But no, this would probably lead to a bias, and it would show more like people like math than actually true. So this is not a good sample, so 1 only is a good answer. Okay? Let's take a look at, let's just skip around a little bit. Number 5, a random sample of 100 people that would best estimate the proportion of all registered voters in a district who support improvements to the high school football field should be drawn from registered voters in a district at A. Well, let's see. 100 people that would best estimate the proportion of all registered voters. Okay, so if you go to a football game, those people are going to want the field to be fixed more likely. It's not saying all of them. It's saying it would not be good representation of the entire population because they're trying to estimate all registered voters. So that's not good. What about supermarket? Well, supermarket's pretty random. Yeah, everyone goes to the supermarket. Let's check out the others. School fundraiser. Well, if you're at a school fundraiser, you're more likely to like the school and more likely to want the school to look better and to be improved. So that would definitely lead to a bias. High school band concert. Now, if you're at a band concert, a couple things I'm thinking here. Either they're part of the school, so they want the school to look better. That could lead to bias. Or maybe they're in the band, they think that sports are stupid or something, or not saying all of them, but there's a higher proportion than the entire population who don't like sports there and therefore might not want the money to go to that. They might think that would take away from them. But either way, there are possibilities of bias. So the best choice here would be to go to the local supermarket and ask the people there. Okay? Uh, this one's always funny. I always think about this. Chuck's Trucking Company has decided to initiate an Employee of the Month program. To determine the recipient, they put the following sign on the back of each truck. The driver who receives the highest number of positive comments will win the recognition. Explain one statistical bias in this data collection method. Well, first off, people don't call 1555 driving to let them know how amazing of a driver they are. That's definitely a flaw in this, is that it would lead to bias because more people would say, I'm going to call only to say bad stuff. But also, who would win this? I guess, if you knew more people, you could just get them to call. This is called voluntary response. And voluntary response kind of sucks because people are only going to call that have really some reason to call. They're not going to call. It's not a random sample. It's not like you can force people and point at the truck and say, call up right now and tell what you think about that driving. So this is not a great, really, method. So any statistical bias in this data collection method, you could explain any one you want of the two that we just talked about. All right, so try out the worksheet and we'll talk soon.